Okay, now good evening, sirs. My name is Pingagia. I am from math241 from section 1, and my major is computer science. And today I will do my term project. The topic is about the linear economic models. Okay, now before we get into the exercise, we must know that what is the linear eco model. In mathematics and linear algebra, a linear economic model refers to an economic model that following the principle of the linearity. Linearity means that the relationship between variables in the models can be represented using the linear equations. In an economic context, such as models are used to study and analyze economic systems, including production, consumption, and investment decisions, under the assumption of the constant of proportionate relationships between different variables. So, you know that in math and linear algebra, the economic is referred to the principle of the linear algebra that we have like an input and output. Okay, now let's get into the first example to make the clearly more understand about it. Like here, okay, let me do it. Here, this is the input of the three elements such as service, electricity, oil, and also all these 10 is the produce this side is the produce side and this side is the consume side. And produce mean that output is also have the three elements such as service, electricity, and oil. And this is all the number that we call in the matrix. And you must confuse or wonder how can we do it in math. Okay, now let's get all of that number into the mathematical form. Here in the mathematical form, in this equation, E x equal to x. This is the form of the linear economic models. And you might be seen a lot of this in the exercise. And to make you more easier to understand about this exercise, you must know that what is 1/4, all x the constant number is an e, and all the x is the x1, x2, x3. And you must confuse or want to know that what is all of this e and x stand for. In matrix E is called the exchange matrix, and the vector X is called the price vector. So again, E here is called the exchange matrix, and V and X is called the price of the vector. It means that X, all of them is equal to price. So in the end of the exercise, we must want to know that the price of its product itself. And in general, E, J, it means that all of this number is represent the function or the percentage. It's either the function or the percentage or the price of the industry output, like output from here, as you can see. And the price change by industry I for the output. In the closed economy, the sum of the column E is 1. It means that all of the elements when we add all together is equal 1. Since the entry of E are also the non-negative, E is the Scotiac matrix of the problem of finding solution to the equation. Okay, now let's get into the exercise 1. Determine which of the matrix is exchange matrix. For the exchange matrix, find the non-negative price vector of the satisfy the equation. As we know, E is the exchange matrix. And what we want to know is X. What is X for? X for the vector price or price of the vector. Now we want to know the price. But we know that EX is equal to, or in another hand, EX also equal this. I will show you how it turns from this into this. Now we want the X on the right hand side to the left hand side. So we write like this, X minus X, because we need to change the from positive to negative and equal to 0. And then we take the X out of here. So we have E minus I equal to 0. Yes, it is simple like that. Here, like I explained you earlier. Now, we know that E, now we know that E is equal to 1 on 2, 1, 0 here, 0, 0, 1 on 3, 1 on 2, 0, 2 on 3. But what is E or I here? I in the matrix, maybe you need to remember it yourself. There is many form of I. If a 2x2 matrix, I is equal to 1, 0, 0, 1. However, for 3x3 matrix, I is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. And this is the 3x3 matrix. It has 3 columns and 3 rows. So we must compute like this. Okay. So we must compute like this. We need to have the E, and then we need to minus with the I. And like I told you earlier, I is equal 1, 0, 0, 0, 1, 0, 0, 0, 1. You must remember it by yourself. So 1 and 2 minus 1 is equal minus 1 and 2. 1 minus 0 is equal 1. 0 minus 0 is equal 0. 0 minus 0 equals 0. 0 minus 1 is equal minus 1. 1 on 3 minus 0 is equal 1 on 3. 1 on 2 minus 0 is equal 1 on 2. 0 minus 0 is 0. 2 on 3 minus 1 is equal 2 minus 3 on 3 is equal minus 1 on 3. Now we get something like this. It is so simple. And in order to get the answer, we need to have this into 0. Also, that's 1 into 0. And we want this, we want this number equal to, no, I mean like we want 1 and 3 into negative, because in order to get both of these are the same, so we need to multiply minus on the row 2. So, and row on the row 1 we keep it the same. Row 2 we multiply minus, so from the negative to positive and from positive to negative. And this, when the my 1 on 2 plus minus 1 2 is equal 0, it's equal 1. Here 0 plus 1 is equal 1, and minus 1 on 3 minus 0 is equal minus 1 on 3. And then we need to compute in order to get this row 0. So when we get the answers, so when we get so when and here, and we want this into the I form. Yes, and here is the answer, as you can see. So we need to set T for 3. Oh, I forgot to tell you. It's negative, but in the reality we don't take it negative, we take it only the positive number of it. So x1 is equal to on 3 T. Why T? Because we take it out from here, and then we need to set the price of T. We can set any number you want, but here at x2 is equal to 1, 3. So when we have the under is 3, so we need to multiply with 3, because we will have all of this number. It is easy to compute. That's it. And another point is linear open models. The matrix linear open models. The matrix C is called the consumption matrix, and X is the production vector, and D is the demand vector. So C is the consumption matrix, X is production vector, it's not price anymore, and D is the demand vector. In general, if C, X, and D represent the dollar values of industry I output, and then it's going to produce $1 of the volt of the industry chase output. X is the dollar price of the vector of the industry I output, and D is the dollar value of the external demand for industry I person. Sorry. And once again, we are interested to find the production vector S with non-negative entries, such as at least one entry in the positive. So this is the example. We have X here. This is the C, also X. This is the D. The D is equal to the demand vector. C is the consumption, and X is the production vector. Here, as you can see. And here is the sample in order to C, X, X, and here's the demand in order to know what it is. And we must in order to compute this, we want to I minus C, and then when it I minus C is invertible. If it's not invertible, it means that the consumption is not productive. Okay, now let's get into the exercise. We have C, the consumption, and D is the demand vector. So like I told you earlier, this is form for 2x2 matrix, and we need to minus with the minus to the number that the exercise gives us. And here we get, so in order, and then when we find the answer of the E minus I, we need to find the inverse of it. And when we get the inverse of that number, we need to take the inverse of the I minus C and multiply it with D. D is 2 and 1, like the exercise gives us. And then that is all of answer when we compute all together with the help of this answer. And this answer is the feasible production X that satisfy to the equation. And that is all of my presentation. Thank you so for the listening.